All right, let's look at the homework 5.5, problem number 9. All right, so we have a couple of parabolas and x-axis. Then we want to find the area of the region bounded by those guys. All right, so let's find the correct picture. So you have two parabolas, right? So maybe we should rewrite them first. All right, so we can rewrite these guys as, by completing the square, we have x minus 5 squared. And the second one is actually simply x minus 9 squared, right? So it's just simply a parabola shifted to the right 5 units and also 9 units. All right, so let's, I'm going to cheat a little bit. I'm going to use the GeoGebra to demonstrate this. All right, so I'm going to sketch the picture x minus 5 quantity squared. So I'm going to call f of x is equal to x minus 5 squared. So it looks like that. The other one is I'm going to call it g of x is equal to x minus 9 squared, right? So we have that. So the region is right here, right? So I'm going to just indicate it, integral. All right, I'm going to integral f from, looks like it's going to go from 5 to 7. So 5 to 7. All right, so you have the region there. All right, then the other region is under f of x, so integral g, you're going from 7 to 9, all right? So we have that. So combination of two is going to be the answer. All right, so let's go back and define the correct region here. All right, so first one doesn't look like it. Second one, it's very similar, but the location is messed up. It's a 6 and 8. That's not right. This one is upside down. Right, so this is the correct picture. All right, have that. All right, let's check the answer. All right, I came back and looks like we have chosen the correct picture. All right, so let's find the area. All right, so if you look at the GeoGebra here, so the region here and the region here, you combine those two. And you can see that they are exactly the same area. So I'm going to just focus on finding one of them, and then you just have to double it, right? All right, so to make our lives easier, we could use this original function here, but what I'm going to do is I'm going to actually move it over to the origin so that the function becomes a lot simpler. All right, so we can just do, let's see, I'm going to use a slider so that I can kind of animate it. All right, so I'm going to use t. T is just going from 0 to 5 or something like that. And the increment is 0.1. All right, and then I'm going to, let's see, change this. So I'm going to change integral. Actually, integral was this one, right? So I'm going to move this, slide it over to the right 5 units. So to do that, I'm going to use the slider to move it over. So you have a x plus t there, 5 minus t, 7 minus t, right? All right, as you can see that here we can slide this region over, right? To get there. Actually, I have to slide the graph over too. So I'm going to just write the y equals f of x plus t to slide it over. All right, so you can see I'm going to go back. All right, here's the original region. All right, I'm going to move it, just slide it without changing the shape. All right, and the area is exactly the same. All right. If you slide it over, you can see that this is just going to be an x squared. If you simplify this, 5 cancel out. So it's y equals x squared. And the region is only going from 0 to 2. Because it used to be going from 5 to 7. So you have a gap of 2. Now it's moved to 0. So it's going to go from 0 to 2. Right? So we can find that area. Then you just have to double it. Right? So let's do that. All right, so we have area A, and we just need to double this. And the region is going from 0 to 2 instead of 5 to 7. Then function is just a simple x squared function, right? Then we can just simply find an antiderivative, which is x cubed over 3. And then you're going from 0 to 2, right? Then this is going to be 2 times plug in 2, so 2 cubed is 8 over 3, and plug in 0 is 0, so I'm not going to even write that. So this is going to be 2 times 8 is 16 over 3, right? So this is the area of the region, right? Let's type it in. Right, we have, so we have a 16 over 3, right? Let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.